Hi, so we will now study the convex function and the concave function, and these terms will be very much necessary for the coming course. So let's see what are they. So basically, convex function is a function or a region is convex if we take any 2 points in between the region and it lies within those. So for example, we took these 2 points and they are within its region, or we can say above it. Similarly, in the circle we took these 2 points and they are between its domain or in region. So for a function we can see that, so to check whether a function is convex or concave, so its second derivative must be greater than 0. So for example, we took y is equals to x square and its first derivative 2x and its second derivative is 2, which is greater than 0, so it is a convex function. We can check it out in here. So for example, we took x square, so this is a convex function. As we can see, it is a U shaped, and if we take any 2 points between them, it will lie between its region. And now if we take second derivative, it is an increasing function, or you can say a non-decreasing function. Second derivative is greater than 0, and the slope of its first derivative will be not decreasing, so we can also check that out. So we took the first derivative, which is 2x, and we can see that it is increasing, and for this it is non-zero. The second derivative is non-zero, and here we can see that. Yeah. So now coming towards the concave, so the opposite of convex will be concave. So in convex we said that it will be a region shaping upwards like a cup, but it is concave is like a cup facing downwards, and here we can see that it is a cup facing downwards. And so if we take, it will be, you can check from a region or from a graph that, for example, we took these 2 points here, so this is the region, but this 2 points, when we join them with a straight line, this part is outside the region, so it is not a concave. Similarly, this for example is a whole structure. I will draw it here, like for example, so if I took 2 points here and joined a straight line, something like that, so it will go outside. Similarly in here, if we join these two, this will come outside. Similarly for a shape like this, like this, like this, for example, this is a complete shape, and we took any 2 points here, and this will be outside the region. So for example, in terms of function, so that its function will be less than 0. So here we took the function of y is equals to minus x square. Now let's check it in the graph. Minus x square. So you can see that it is like more like a downward function, a cup facing downwards. And if we take its second derivative, it is less than 0. So now we will confirm it. Minus 2, it is less than 0. Yeah. And the slope of the first derivative is not increasing, or we can say that it will be decreasing. So we can see that the slope of the first derivative is decreasing. So here are a few tricks that we can check from a function or equation that it is a convex or concave. So let's see. So a constant function will be convex or concave. So mostly it will be like both convex and concave. Linear function will also be either a convex or a concave, like it will be both. In quadratic, it will depend upon, mostly it's the first coefficient of a. So we know that for quadratic, so it's more like y is equals to ax square plus bx plus c. So here it will depend mostly on this term, whether it is positive or a negative. So if it is greater than 0, it is a convex, and if less than 0, it will be a concave. And so let's see. Yeah, so we said that we take a positive quadratic equation and check whether it's a convex or concave. So we say that if a is a positive, it will be a convex, but if we change just the sign, it will be negative. So it mostly will depend upon this term. If we do changes here, -8, it will not have that effect, and similarly if we change the second term, it didn't have that effect. So it will mostly depend on this first term. So if you can see that the first term of the quadratic function or the x square term is negative, it will be a concave. So this was all about today, and let's see you in the next class.